Hi, I am Sofia Herrera, and in this session, we will be discussing EMS and BESS analytics and how they maximize availability and extend the long-term economic lifetime of battery energy storage systems. We will also explore why these analytics are so critical to ensuring full end-to-end oversight across the entire life cycle of BESS assets. Joining me to dive into this topic is Vaso Kaczynski, Senior Product Manager here at Power Factors. Vaso, to start things off, could you tell us a little bit about yourself?
Hi, Sophia. Thank you very much for having me. So, I'm an electrical engineer. I have 14 years of experience in the energy sector, with my main focus being on renewable energy and energy storage systems. Currently, I'm a senior product manager here at Power Factors. I'm part of EMS product team, which has deep expertise and a long-standing track record in monitoring and managing energy storage systems. To give a sense of scale, over the past decade, we've worked across a wide range of battery chemistries, from lead-acid to redox flow and lithium-ion variants such as NMC and LFP. We have supported deployments from commercial and industrial setups to utility-scale installations, with the latter, the utility-scale BESS, being at the heart of what we do. Indicatively, Power Factor's EMS solution is currently managing more than 24 gigawatt hours of BESS assets globally. Our work has earned industry recognition, with Power Factors ranked among the top 3 EMS vendors worldwide by Guidehouse Insights.
Thank you, Vaso, for that wonderful introduction. Now let's start with the first topic of the session, EMS monitoring and analysis for smarter BESS management. As utility-scale BESS projects become larger and more complex, the need for a sophisticated analytics layer in a future-ready EMS becomes very clear. Power Factor's EMS is purpose-built to meet the challenges of today's utility-scale BESS projects, designed from edge to cloud, with a focus on scalability, data transparency, and actionable intelligence. It empowers operators with the tools they need to monitor, analyze, and optimize battery performance across the full system lifecycle. Vaso, can you tell us more about how analysis and control complement each other, resulting in optimized BESS performance?
Absolutely, Sophia. So, in battery energy storage systems, optimized battery operation ultimately translates into 2 main objectives. First, maximizing asset availability, which drives revenue, and second, minimizing operational stress, which directly impacts degradation. This trade-off is where the real value lies. Regarding BESS availability, there are multiple real-time factors that can influence it. These range from equipment capability, actual state of charge and available energy to charge and discharge, to safety-related operational limits that are tied to cell voltage, current, and temperature. As an example, if a single cell temperature rises above a certain threshold, this can trigger the battery string that contains the cell to disconnect for safety reasons, and this directly impacts availability. If on top of all this, we also add warranty-imposed constraints that set boundary conditions on battery utilization, and if we also add natural capacity degradation of their time, it becomes clear that a fine overall balance needs to be maintained. That is why having multi-layered analytics is so important, starting from the site level and going all the way down to individual battery strings, or even at substring resolution. When these analytics feed into adaptive real-time set point distribution, they unlock the ability to operate the BESS optimally, maximize availability, protect the battery during operation, and just as importantly, stay within warranty limits. Take, for instance, resting state of charge, power rates over time, or usable energy capacity that includes the state of health of the battery. These metrics, standalone or combined, gives us a deeper operational context, the one that we need to make smart and informed decisions. And with that insight, we can define individualized control strategies, not just across the site, but per AC power block, or even on the DC side per battery bank.
Thanks, Vaso. Very interesting. So it's fair to say that our EMS empowers optimized BESS performance through real-time multi-layer analytics, maximizing availability, minimizing stress, protecting the battery from excessive degradation, and ensuring that the operation stays within warranty limits. But how exactly can our EMS support this full circle approach, and what are the key components to creating deeper insights and enabling analytics-driven control?
Okay, so first of all, combining edge processing with cloud analytics unlocks a powerful layer of insight. Let's give a few examples. If we look at BESS utilization metrics like cycle time, state of charge, and temperature exposure, these tell us a lot about how degradation is actually building up over time. Then we have imbalance analytics, which are just as important. These help us uncover hidden inefficiencies that wouldn't typically show up in traditional monitoring. But when we apply advanced analytics and when we dynamically compare sibling battery segments like battery strings and battery enclosures, looking at metrics such as voltage current, state of charge spreads, then we start to see those subtle signs of asymmetry that actually impact performance, availability, and health over time. Another key piece is the ongoing assessment of how your battery is performing against contractual obligations. These analytics can help you figure out if your current operational patterns are still on track for long-term compliance or if you need to adjust, maybe even trigger a warranty restoration strategy. And that is where visibility becomes critical. It's not just about having the data and the analytics, it's also about showing what matters. Smart visualization tools can cut through complexity and bring the right issues to the surface, whether it's anomalies or outliers or weak links buried deep into the system. Okay, so up to now, we've mentioned two elements, the edge cloud analytics and the smart visualizations to make sense of complex data. Both are absolutely essential, but an insight-driven EMS goes even further. It actively supports decision-making and automation based on these analytics. Insights are transformed into optimized control strategies and maintenance automations, reducing downtime and operational costs while enhancing long-term asset performance. And of course, being able to perform real-time analytics-driven control and optimization effectively and at scale requires the right foundation. A robust edge infrastructure ensures scalable performance and responsiveness, even in large, data-intensive utility-scale deployments. On top of that, high-resolution telemetry gives you the level of detail needed to track service delivery accurately, to spot imbalance dynamics as they unfold, and to react quickly to operational events. And finally, the transparent, traceable data handling from edge to cloud allows operators to act confidently, backed by data and auditable insights that support both operational decisions and long-term compliance.
So, an insight-driven EMS, like ours, is combining edge and cloud resources, transforming high-resolution data into actionable insights while delivering intelligent and reliable energy management. One of the points you mentioned is how the EMS needs to go beyond just monitoring, actively delivering smarter decision making and automation across the entire BESS lifecycle. And this concept opens the floor for our next topic. Part 2, maximizing BESS availability, turning analytics into revenue efficient maintenance automations. We have talked about how analytics can inform smarter operation and control. Now let's focus on another critical operational challenge in large-scale BESS and the role of analytics in maintenance strategies. Vaso, could you please provide some context around this topic?
Absolutely. Let's begin with a little context. So, utility-scale BESS systems involve thousands of battery cells and also numerous inverters, control electronics, HVAC systems, fire suppression systems, so on and so forth. So maintenance coordination across these components seems naturally complex and costly. It can involve various vendors and specialized technicians. And on top of that, maintenance operations serve as regular health assessment milestones and are used as measures to address imbalance operation. So when maintenance is infrequent or reactive, it opens the door to faster degradation, capacity loss, and in some cases even safety concerns. And that can quickly snowball into underperformance or warranty breaches. Operational imbalances are a big part of that story. They are spotted through voltage, current, temperature, or state of charge anomalies, either within a battery string or across multiple battery strings connected in parallel. Imbalanced operation can result from a range of factors. This can be manufacturing tolerances at cell or module level, DC bus configuration, BMS miscalculations, or thermal design limitations inside the battery containers. You can start seeing the result of imbalanced operation with two key impacts. First, in real time, the system's available energy is limited by the weakest link, so your performance takes a hit. Second, over the long term, you see an even degradation driven by things like temperature rise or how long batteries rest at marginal state of charges. This can end up cutting the lifespan of parts of your battery much faster.
Vaso, you mentioned BMS miscalculation. It is a well-known issue in the industry that batteries require regular resetting due to the fact that the BMS state of charge estimation trends to drift over time.
Yeah, sure, that's a fact and a big chapter in BESS maintenance. LFP batteries require periodic recalculation to reset and update the BMS state of charge estimation because the state of charge inference degrades more quickly and accumulates errors. The frequency that recalibration may be needed varies depending on application, age of the battery, and operational cycles, but we've seen that it can be as often as once a month in certain cases. Recalibration cycles require taking the system or part of the system offline, which affects availability and potential revenue during that period. Every hour of best downtime that is used to balance or recalibrate the battery is a lost opportunity to deliver energy services through frequency regulation, peak saving, and so on and so forth. This can heavily impact a project's ROI depending on the frequency of maintenance routines, and especially in high-value markets. That's why solutions that enables analytics-driven, automated, and selective maintenance strategies are increasingly valuable. They help reduce cost, minimize downtime, and maximize availability.
And how exactly can EMS analytics and automation help optimize maintenance activities in utility scale BESS while minimizing downtime and protecting return on investment?
So, EMS analytics become a game changer as they identify and flag issues, but also trigger targeted maintenance that maximizes system uptime while protecting long-term asset health. Let's break it down. First part is all about detection. We're talking about tailored analytics that monitor battery behavior based on, for example, cell voltage anomalies, abrupt state of charge transitions, cumulative throughput, downtime, and efficiency metrics at battery string level. Add to that current distribution and temperature anomalies across strings, and now we're really starting to see the full picture. The role of UI here and the role of smart alarm management is equally crucial to support early intervention. The second half of the solution is triggering maintenance automations, which allow actions to be taken only when needed and in ways that don't disrupt contracted services. That's where a smart EMS can make a difference, going beyond issue detection and using the analytics to trigger automation that's optimized for revenue efficiency. There are two key enablers of this. First, flexibility, allowing the formation of individual clusters, either statically or dynamically, and providing the ability for them to be managed independently so the rest of the plant can remain online. And second, intelligent scheduling automation, where the maintenance sequences are aligned within import-export obligations of the site. So even while part of the system is undergoing maintenance, the plant can continue delivering on its service commitments. On that basis, EMS automations can make it possible to align maintenance actions with actual service delivery obligations. So even while part of your system is being serviced, the rest of it is still working and still generating revenue. That's the kind of intelligent orchestration that makes a real difference.
So it's all about closing the loop between detection and action. Our EMS transforms analytics into intelligent, cost-effective, revenue-focused maintenance strategies, detecting issues early, triggering precise, non-disruptive actions, and orchestrating flexible, automated schedules that keeps the storage system online, maximizing revenue at all times. Until now, we have covered how monitoring and analysis empowers EMS to apply strategies to mitigate the impact of suboptimal operating modes and imbalances, which degrades the battery health in the long run. Now, let's touch our last topic for today. Part 3. Unlocking value with BESS Edge Analytics for optimized warranty abating operation. BESS warranty management can get extremely complex, especially with the introduction of performance guarantees, which can also have many layers. Vaso, how can the EMS factor in warranty management into day-to-day BESS operations?
That's true. Beyond the traditional warranty envelope, which defines the operating boundaries to keep the battery protected and compliant during real-time operation, there's another important piece of the puzzle: performance guarantees. These go a step further. Unlike typical warranty limits, performance guarantees are often tied to the cumulative usage or stress on the battery. This is measured over longer time frames, typically annually. What this means in practice is that operators have a bit more flexibility. They might temporarily push the limits of throughputs or power rates, for example, as long as those periods of aggressive use are balanced out later with more conservative operation. But to do this effectively and without risk, we need adaptive control strategies and automated restoration mechanisms built into the EMS. That's what allows us to manage these trade-offs in a smart, safe, and performant way. And then there's a third, increasingly common layer: flexible performance guarantees. These allow operators to go outside predefined usage limits, but with the understanding that doing so will impact the degradation trajectory and therefore the minimum guaranteed capacity from year to year. In other words, there's more flexibility, but it comes with direct trade-offs that the EMS needs to track and manage proactively.
And how can the EMS manage that sweet spot between utilization and protection?
To start with, the EMS should be able to continuously analyze metrics tied to warranty terms and subsequently flag when things start drifting and even enforce warranty abiding operation. On top of that, a built-in flexible warranty management framework adds even more value. You don't just monitor performance, you track trends over time using longitudinal analysis, and you continuously check this way compliance with contractual guarantees. So operators not only know where they stand today, they also know where they're headed. It's about proactive compliance in the frame of flexible performance guarantees. Furthermore, if an EMS detects that the battery is approaching a degradation limit or a utilization threshold that requires intervention, it can automatically adjust set points to ensure compliance or even apply conditionally a more complex restoration strategy for a certain period of time in order to recover performance. This gives operators the best of both worlds. First, you get flexible, high availability operation that still abides by warranty terms. Second, you avoid leaving revenue on the table by running too conservatively. That could be a common pitfall, playing it too safe and missing out on asset value. So with adaptive control and smart warranty management built into the EMS, you don't have to choose between utilization and protection. You can have both and you can do it with confidence.
So, this is really about turning analytics into action, right?
Exactly. It's not just about keeping your BESS online, it's about delivering power smartly. And to do that, you must measure, track, and adapt, especially because performance guarantees are tied to long-term value. Our EMS provides the tools to do just that.
Right. So, an adaptive EMS with a robust BESS analytics layer doesn't just extend battery life. It ensures you're getting every dollar of value out of your asset without compromising performance or compliance.
Exactly, yeah.
Well, that brings us to the end of the session. To quickly recap, we have explored key elements of a full circle of BESS monitoring and analysis, from hybrid edge cloud insights to detect imbalances and maximize availability to cost-effective maintenance automations, and finally, the transformative role of analytics in driving smarter, warranty-compliant BESS operations. Vaso, you have given us a powerful perspective on how analytics and automation aren't just technical tools. They are enablers of long-term asset performance, cost efficiency, and commercial success, especially in today's market, where every megawatt hour counts. Being able to operate your storage assets intelligently and adaptively isn't a nice to have, it's a competitive necessity. Vaso, thank you so much for being here with us.
Thank you, it's my pleasure.
To our viewers, thank you for your time. We hope this session gave you both insights and practical takeaways on how to manage utility scale BESS projects. If you have any questions or want to dig deeper into what we have covered, please reach out. We would love to continue the conversation. Thanks again, and until next time.